Hello, sir. Good evening, sir.
Good evening. Good evening. This 1 minute we are starting. Today we'll be doing oh,
Good evening, sir. Good evening, sir.
yeah, good evening everyone. Good evening. So we'll be doing some natural phenomena, right?
Sir, we don't have metals and non-metals, sir.
Do we have metals and non-metals? I
Sir,
think we
like,
did that. Yeah, I think we have done that also. Yeah.
okay, sir, like, we don't have in our textbook, but the ma'am told that we have it for finals.
Like so we'll be doing some natural phenomena, right? Since we have a test from that chapter, natural phenomena in the coming Sunday. We will quickly revise that.
Yes, sir.
Yeah, Pranav will be going. See, in the last two classes, we have done that only. Right? We have done higher levels only. Okay, so today we'll be revising according to the syllabus. This one chapter. So you should also not be getting poor marks in your exams. Everyone should be getting good, excellent marks in their exam. All right. So along with the competition, we also have to prepare for our exams. Hmm. Oh. So a few of the natural phenomena which we'll be trying to study here in this chapter. We have to study about thunderstorms, and earthquakes. So these are the two natural phenomena which we need to study: thunderstorms, earthquakes, lightning. These are the natural phenomena which cause a lot of damage to the life and property. So some of them, by studying them, we try to understand how these phenomena occur, and we try to make ourselves safe from them. Okay, since these are the natural phenomena, they can happen anywhere. So like earthquakes, they are unpredictable. They can happen anytime. So earthquakes are unpredictable. Lightning is almost, it's predictable, but its place is not predictable. We know that when it's raining, that is the time there can be a lightning or thunderstorm. The first natural phenomena that we'll try to understand is lightning. How does lightning occur? To understand the lightning, we must understand the charges and what happens when the charges pass through air. Okay. The basic of the lightning is in the charges. So we, in our daily life, we come around or we interact with the charges which are very small in magnitude. For example, in the winter season, when we wear the woolen clothes or we are wearing the blanket, and if we open them up, we hear some sparkling sounds produced by them, and some sparks also being produced by them. Okay, so all this happens due to the charges. So charges, they are the property of matter, and they can be of two types. They can be positive charges as well as the negative charges. Hmm. Very good. Okay, Pranav, so that's good that if you have understood this chapter, you will make us explain this chapter. Okay, you will explain this chapter wherever it's required so that everyone gets something about this chapter. All right. So, Pranav, 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 there is a large electric discharge that occurs. That means there is a flow of large amount of charges when it's lightning. So, how the lightning occurs? So see, we have two types of charges, the positive charges and negative charges. And we know that these oppositely charged particles, they attract towards each other. They are attracted towards each other. So these positive charges, they are attracted towards the negative charges. Got it? And therefore, they get attracted towards the negative charges. But if we have air in between them, so air is an insulator. Okay. Since air is an insulator, it opposes the movement of the charges. Still, if the charges are brought very close to each other, so the charges, they travel towards each other even through air, producing sparks. So the same charges, when they travel through a conductor, they do not produce any sparks. Like if you connect the same thing, if you connect two charges over here like this, positive charges. Like so, see, if you place a conductor, here we place a conductor, and let's say we connect one end of the conductor with the positive terminal of the battery and the other end to the negative terminal of the battery. So will there be any movement of the charges through it?
Yes, sir.
Yes,
Yes,
ma'am.
there
Sir.
will be a movement of the charges. So will there be any sparking produced?
No, sir.
there will not be any sparking produced. Right? Then, why are sparks produced when the charges are passed through air? And why can't the charges pass through air?
Sir,
Yeah.
you mean the current flow?
See, we have the two places. Like here, if I have some amount of positive charges, and here I have
Yes,
some amount of negative charges. So if you have air in between them, the charges they do not jump from this one to this one. If there
yes,
is
sir.
very large amount of charge, then only the charges travel from one point to another through air.
Yes, sir.
Then only they travel through air. So there are sparks produced. Here, through a wire or through a metal, a lot of charges are traveling.
Sir,
One is
because
connected.
air is not a good conductor.
Yes, air is not a good conductor. Air is a poor conductor of electricity.
Okay, sir. So the metal rod is a good conductor while air is not.
Repeat.
So the metal rod is a good conductor while the air is not a good conductor.
Yeah, metal rod is a good conductor while the air is not a good conductor. Right? So see, when the metal is a good conductor, when it's
They say
when
that charges travel from plus to minus, no sir.
yeah, what
But
happened?
in textbooks they will say the charges start from plus to minus, no sir. But
Hmm.
it's the actual one is minus to plus, no sir. Because
Yeah, that
negative ions are only active.
yeah, it's the negative ions which travel and they travel from the negative terminal to the positive terminal.
So why we say like that, sir?
It's just the conventional sign conventions that we have taken. See, motion is relative. There is no motion that you can say that this is a real motion.
Yes, sir. Oh, I forgot that. Okay.
Okay. So motion is always motion is relative. Motion is never absolute.
Yes, sir. Yes, sir. I read
Uh,
the relativity.
yes. So if you are sitting in a bus and you see the objects to be going backwards,
Yes, sir.
all right. So you know that you are moving, but it can be said that the trees are moving, the road, the other things are moving with your respect.
Yes, sir.
Okay, with respect to you, other things are moving. So you can't say that other things are not moving. They are moving.
Yes, sir.
Okay, but with respect to you, they are in motion. Got it?
Yes,
So motion is never absolute. And that's why if you either you consider the motion of the negative charges or you consider the motion of positive charges, it remains the same. And why we took the positive ones? Since conventionally we have considered the motion of positive ions only. Okay, everywhere all the other terms they have been defined in terms of the positive charges. So to keep it the same, we accepted that we'll be considering the direction of current to be from positive to negative and not from negative to positive. Got it? Yes, Pranav. Pranav.
yes, sir. Okay, sir.
Okay. Now see, can anyone explain? Okay, so we got it when the charge, first of all, the charges will not travel through air. This is clear that the charges are not going to travel through air. They can surely travel through a conductor or any metal. Like charges can easily travel through a conductor. They can pass through a conductor. Even large amount of charges can pass through a conductor, right? But they cannot pass through air. Now, obviously, I know that the charges cannot pass through air. But what will happen if the amount of the charges is too large? Yes. What will happen if the amount of charges is too large, too big? So if the amount of charges is
Sir,
too big,
can you repeat it? Sir, once can you repeat your question?
so, I told you that if you have a positive charge and a negative charge, right? So these two charges, they get attracted towards each other. Got it? But they are not going to pass through air. So here you have some amount of charges. Here you have some amount of charges. Here you have some positive charges. Here you have some negative charges. The charges are not going to move through air, as here you have air, which is an insulator. But if you increase the amount of charges, if you increase the amount of charges over here and amount of negative charges over here, so the charges, they will be traveling from they will start traveling. All right. So here, when the charges increase in high quantity, a high voltage is set up over here, and therefore charges start to travel.
Sir, I have a doubt.
Yes. Yes.
Sir, so air will remain as insulator, but the charges as they grow, it will pass easily.
What happened?
Sir, so air will remain as insulator, but if the charges at both the ends grow, means become larger, they will pass easily if there is a high voltage.
No, they will not pass easily. See, the charges are getting attracted towards each other. Okay, these positive charges, they are attracting the negative charges. The negative charges, they are attracting the positive charges. All right, but air is opposing their motion. Air is in between them, which is opposing their motion. Okay, so for how long air can oppose? If there is a limit of the opposition that air can have. So when the voltage increases too much, then at that point, air is no more able to stop the charges. Got it? And therefore, the charges, they move through air at that point.
Yes.
All right? So this is the phenomena that occurs when we have lightning. There is a development of heavy negative charge in the clouds. Okay? Those heavy negative charge in the clouds, they get attracted towards the positive charges on the surface of the earth, which are developed by the trees.
Sir,
Hmm?
why electrons attract to positive, sir?
Okay, why attract? There is no such thing. This is a natural thing that the opposite charges attract each other.
But I believe in reason, sir.
Hmm?
I believe in reason, sir.
Hmm. So the reason was explained by the field theory, the field that they set up. Okay. Positive charge, it sets up a field which is outwards, whereas the negative charge sets up a field in the inwards.
Yes, sir.
Got it? So there can be various reasons. You can say the field concept or even the potential concept, that the charges move from high potential to a low potential. Got it? So wherever you have negative charges, that is a low potential. If you have positive charges, that's a high potential. Got it? Thank you. What are charges? So charge is just a property of matter. Just like you can say matter has mass. In the similar way, we say that matter has charge. Matter can have charge. So understood, Pranav?
So today we'll be doing worksheet also.
No, not today. In the next class,
Okay,
we'll be doing
next
worksheet from
class.
this.
Okay, so we will not metals and non-metals usually will be done next in this week.
In this book,
No, sir, I mean like metals and non-metals revision is not done next week.
yeah, revision is not done for that chapter.
Okay, sir.
We have started revision, so one by one we are doing the chapters, right? So see, that's the reason why we have lightning. So why lightning occurs? Due to the motion of the water particles or water vapors. When water vapors move upward, okay. Now Pranav will explain. Pranav,
Sure.
yeah, how are charges developed in the clouds?
Sir, heavy droplets of electric charges. That's why they go to the bottom end of the cloud, and the positive charges have lighter density, so they go to the upper part of the cloud, sir.
Okay, so how are the charges developed over there?
Sir,
How
the friction between the water droplets, sir,
the friction between the water droplets and
and the friction between the water droplets and the electric discharge, sir.
no, you are halfway correct. It's the friction, all right? So when the water droplets are rising up, since the water droplets are lighter, they rise up. So when they rise up due to the friction by the dirt particles, due to the friction of the dirt particles present in the air, when the clouds get charged, right? There is a heavy charge developed in the clouds. And that heavy charge which is developed in the clouds, it gets attracted towards the earth. So it gives rise to the phenomena called lightning. So in one word, if you want to say
Sir,
how are charges developed in the clouds, it's by friction.
sir,
Hmm?
uh, can we can we derive energy from a fork lightning?
Can we derive energy from?
Fork lightning, sir.
Hmm, I didn't get fork lightning.
Yes, sir. If lightning falls on the earth, sir, can we derive energy from it, sir? Also by
Hmm.
protecting it from people.
Hmm. You can use it, but certainly it's not known that where a lightning will occur.
Yes, sir.
It's unpredictable, all right?
Yes.
And also there is very less time. So you don't have a mechanism to store that electrical energy, all right? Whatever electrical energy is created over there. All right. The next question, what is lightning? Okay. So what is lightning? Charantesh, can you say what is lightning?
Lightning is a huge electric discharge formed in the clouds, sir.
Okay, it is a huge electric discharge, all right? We noted. So lightning, it is a huge electric discharge. A huge electric discharge from clouds towards ground. Got it? Now, is it harmful? Yes, it's harmful. Like if it falls on someone, the person may get injured or the person may get die.
Sir,
The person may die. Yeah.
sir, lightning even means that sudden spark in the clouds.
Yeah. It's a spark which is traveling from cloud to the earth. So it can fall anywhere on the earth, but the general places where it generally falls closer to the trees. Okay. Now, what places are safe?
Sir, rather than standing under a tree, we should move to a safer place.
One.
We should not stay under the trees, sir.
Okay.
High
What are
trees.
what? Okay. What places are safe? First of all, make a list of the places. Lasya, can you tell what are
Below
the
the
places?
table.
No, we are not talking about
Yes,
earthquake. We are
sir.
talking about lightning.
In shelter, sir. In shelter, like any house building.
Yes, sir. You called me.
Yeah, Lasya, I want to ask you what places are safe. So, what
For
places are
hiding
safe?
from
Hmm?
earthquakes,
Yeah, no, from the lightning.
from the lightning.
Where all we
Sir,
are safe?
we have to stay near the no, we shouldn't stay near the
No,
electric
which,
poles.
but where should we stay? That's what I'm asking. What is the safe place?
So anywhere
Far away from the buildings.
Away from the buildings? No.
Sir, in an
so away
open
from
ground
the
or open
windows.
place.
We
Hmm?
have to keep our head down and we have to like a bowing position. We have
Okay,
to
okay, see,
be
the places which are safe
Under the
inside the house, which has
lightning
lightning
conductor.
conductors, right? Then you are safe if you are in your car. Okay, in your car, you are safe, all right? And where you are not safe. So first
But
of all,
open
whenever
places and electric poles, sir.
sir,
okay,
even under the
okay, where we are safe, that means you can take a
So near
shelter
the
under
windows also.
near the windows, all right? Okay, now not safe. The places which are not safe.
So near water bodies.
sir, under
Okay,
the
under the tree, this is not safe.
Near electric poles.
Okay, near electric poles.
Sir, near open spaces, sir.
Open and current generators.
Near electric poles, all right.
Ma'am,
In
sir,
plain
near
ground, sir.
transformers,
Like
sir.
empty grounds.
Sir, near
Eh,
transformers, sir.
All right, well, that we understood near electric poles. That means you have to be stay away from the electric equipments. Okay, then also while thunderstorm, we must put off. Now these are the safety measures. Let me see. Safety measures that we think of. So for the safety measures, we have this. So switch off your electric devices. Switch off electric devices
sir.
like refrigerators.
Do not look at the lightning, sir. It may affect
Uh,
our eyes.
uh, it's not that thing. It's not that harmful, you can say, right? So you need to switch off your electric devices like refrigerators and refrigerators, TV, all those are the devices which you need to switch off. Then when lightning is occurring, then you have to keep inside the
Sir,
house.
you should not even keep mobile charging or use it.
For mobiles, we can't say. As the radiations of the mobile, they are non-ionizing. Okay. So, all right. Right. Keep inside the house, and when you are outside, you are safe under your car, safe in your car. Then, when you are outside, if you don't find any shelter, so if you don't find shelter, then what you should do?
So go to the basement.
Obviously, there is no shelter, so you will kneel down.
Like a bowing position.
Yeah, that we call as kneeling down. Got it? So you kneel down. These are the safety measures that should be taken. And also, while building the houses, you should put lightning conductors. Okay, so use lightning conductors.
Sir, like earthquakes, I'm sorry, sir. Earthquakes mostly occur in Uttar Pradesh side, right,
These,
sir? So like that,
this is not about the earthquake. Currently, we are doing lightning.
yes, sir. So like
Thunderstorm.
lightning only, there is all. So like lightning only, there are some places where mostly lightning occurs.
No. Lightning can occur anywhere. Okay, lightning and thunderstorms, they can occur anywhere, wherever it's raining. Generally, the rainy seasons are
Okay, sir.
there. Okay. All right. So in the next class, we will be doing a little bit about earthquakes. Okay.
Sir, don't remove the
Please.
screen, sir. 1 minute.
Okay. Right.
Just a minute, sir. Done, sir.
Well, all right. Okay. Okay. Bye, everyone.
Thank you, sir.
Right.